Okay, so today we are going to be subtracting real numbers. Now, probably when you learned this in middle school, they probably did a separate section on subtracting integers and then subtracting fractions and subtracting decimals. But notice our heading is real numbers. So within this one lesson, we are going to cover all three of those things. We are going to cover subtracting integers, subtracting fractions, and subtracting decimals. So here, the definition of subtraction, they're telling you that for all real numbers, the difference could be defined by adding the opposite. So this is where, when I teach it, I talk about a keep, flip, change. So for example, their rule here is A minus B. So what I would teach my class, or what I'm going to teach you guys, is to keep the first number the same, change the subtraction to an addition, and then change the last number to its opposite. And that's what they're saying in here as the definition of subtraction. So either you do stay, change, change, where you change the subtraction to an addition, and then you change the last number to its opposite. So, for example, if I were going to try to do 3 minus 12, what I'm going to think of this as is 3 plus negative 12. I'm adding the opposite. So notice I could put lines down, change the subtraction to addition, and then change the last number, or the number you're trying to subtract, to its opposite. And then I'm going to follow my rules for addition. Signs are different. I subtract and keep the sign of the bigger number. And I would get 12 minus 3 is 9. My bigger absolute valued number would be the negative 12, which would be positive 12. And the sign on that number was negative. Over here, again, if I think of this as keep, change, and flip, I'm really adding two negative numbers, so I get negative 8. Now, if you can just look at this and see, wait a minute, I got a negative 7 and a negative 1, and I'm going to combine them, and then I'm left with negative 8. Now, notice here, with this negative, negative, so what we're asked to do here is subtract the opposite, or if you think of it as keep the first number the same, change this to a plus sign, and then make the 10 opposite. That's what that definition of subtraction is. Now, sometimes my class would say, oh, this looks like if I just join this, it looks like it turns into a big plus sign. You can also think of it that way. So whenever you see a negative and a negative, turn it into a big plus sign. And then signs are different here. So negative 4 plus 10, I'm going to subtract and keep the sign of the larger number. So 10 minus 4 is 6. My larger number is 10, so it's positive 6. Now, on this one, we sort of saw the opposite of a sum. You can think of this problem two ways. You can either think of it as there's an imaginary negative 1 here that you need to distribute, or just think of it as distributing the negative sign. So you need to do that first. Everybody always remembers to subtract the first y, but then they have to remember that you have to distribute and make the 6 negative. And then here you can see that y minus y is 0. It's gone, leaving you with negative 6. So this is called the opposite of a sum. Or just remember to distribute the subtraction sign or that negative sign. Okay, so here, this will be the type of question that you may get where you're going to get a whole line of numbers and then you're going to perform the operations. So you can either simplify it left to right, or you could pull out all your negative numbers and add them, and all your positive numbers. Generally, if you're going to follow PEMDAS, it tells you to work left to right. And that's what they're doing here. They're taking them two at a time, then they rewrite the rest of the problem, then do the next two, drop down the 4, and then do the last two numbers and work left to right. That's generally the best way. I notice when kids try to pull out numbers, they don't pull the sign with it and they make mistakes. So it's probably best to work left to right. So here, this is the other technique, telling you to group the positives and group the negatives. So you're also got a little sentence here or a phrase that they want you to simplify and then follow the find the answer. You won't have anything like example 2 on the test tomorrow. They're all going to just be questions with the numbers already in there and the signs in there. But let's go ahead and write the expression that represents example 2A. It says here -30 decreased by -19. What do the words decreased by mean? What operation? Subtraction. So in order to set up my expression, I'm going to do -30 minus -19. So the words decreased by are my subtraction sign, and I need to keep that -19 as a -19. And now I'm going to solve this. So again, if you're going to use the definition of subtraction, you are going to add the opposite. So I'm going to change this to an addition sign and then change the -19 to its opposite. Now notice I have different signs, so I'm going to subtract and keep the sign of the larger number, which will give me -11. Now, again, we saw the opposite of a number, or the opposite of a difference or a sum. Remember the word opposite? You can represent it as a negative sign. So to represent the opposite of the difference between A and B, remember the word difference also means subtraction. So to write part B, I'm going to do the opposite of the difference between A and B. And then I'm going to distribute that negative sign that's outside. And this will turn into a -A. And then when I distribute it to a -B, it makes it become plus. So that would be your final simplified answer. When you find the opposite of a sum or a difference, we're going to change the sign of each term in that sum or difference. So notice on example 3, we have the opposite of the difference of x. Okay, and if you did 3 plus 2, what do you get? Okay, and it'll work for multiplication also. But for subtraction, if I do 3 minus 2, what do I get? 1. What if I do 2 minus 3? -1. So this is why subtraction is not commutative, and it's not associative either. So the associative and the commutative property only work for addition and multiplication. Everybody good? Let's try a couple of examples and then I'm going to do a test review with you. All right, so for number 2, how do we do that problem? 19 minus 12, what do you get? Okay. What about number 6? 0 minus -6. What happens here?
You take the two negatives and make them positives, so it's +6.
Beautiful. All right. What about number 10? Okay. So again, you'd make the two negatives and make it a positive, and it would be 10. Let's try number 7. -16 minus 0. Negative 16. Good. All right, so that is the subtraction. And let's see what your homework. All right, so again, your homework is 1 through 42 all. And what we're going to do right now is a test review. And then I'm going to give you time to start the subtraction homework. And then we're going to go over some of the answers for the subtraction before you leave today.